but we're going to use this as a shorthand way of writing. If you, this is our second, or this is our first definition. Back when we looked at slope at a point, if you approach the slope of that point from the right, and it's the same as approaching that point from the left, then we say that the derivative at that point exists. So the slope from the right has to be the same as the slope from the left. That's the best I can do. The best way to understand differentiability is to look at um, cases where we do not have differentiability. What I've done is I've created 3 graphs right here. You can copy down on your paper. And as you do, I just want you to know I made the treats for you because I appreciate how hard you've been working this year. That said, I'm sure that you will have times where you don't work very hard. But I need you to keep up that work ethic and trust me that we are going to cover some challenging material and there'll be times where we go quicker than you'd like, but I need you to keep pace and make this class truly a priority. So. You're going to have a short assignment today, which means you're not going to have much over break unless you've been a putz and haven't been doing your homework. But when you come back, we will have, trust me, this class will have a lot to get to very quickly. So your 16 problems you had on that worksheet the other day, you should have that done over break. No. Yeah. Okay, ready? If you think about a cubic function or a quadratic, something that has a nice shape to it, that's differentiable everywhere. It's what we call nice behaving. These 3 here are not nice behaving. And the last one you might wonder why, but we do have an issue there. Good now? Okay. Your focus during these 3, and these are all the notes that we covered today, but it is imperative that you understand every question I ask and every point that we make, okay? Look at this graph. What is the slope of this function at this spot right here? -1. So if I want to graph the derivative, which I will plot -1. At this spot, what is the derivative? The slope, -1. Again, if I ask for the slope at that point or the derivative, it's the same. Derivative at -4. Derivative at -3. It becomes more challenging at -2. That's where we employ this idea about looking at the derivative from the left and the derivative from the right. Look at the point -2. What's the derivative from the left? What's the derivative from the right? Those are not the same, are they? So therefore, the function is not differentiable at that point. Look to the right side. What is the derivative at all of these spots? 1. So here is what the graph of the derivative of that function looks like. If this is my function, this is the graph of the derivative. It's not differentiable at -2 because it has a corner. Anytime you see a corner on the graph, it is not differentiable at that point. Is that clear? Okay, now look at this. What is the degree of a line? First degree, second degree, third degree? And when you reduce that, you get 0 or a constant. As you can see, I have a constant line here, and I have a slope of -1 the whole time. Slope of positive 1 the whole time. So that's why I have a height of 1 and a height of negative 1. Okay? So that's the graph of the derivative. Anybody guess at which spots on the second one it is not differentiable? Very good. Anywhere where you have a discontinuity, you do not have a derivative. It is not differentiable at a discontinuity. Furthermore, it's not differentiable at an endpoint. Look at negative 6. The derivative from the right is, what's the slope this way? Positive 1. What's the slope this way? There's nothing, correct? So therefore, you cannot have a derivative at an endpoint. It's differentiable from the right, but not from the left. So let's mark this out. The derivative at negative 5 is 1. The derivative at negative 4 is 1. You see that the derivative is a constant of 1 that whole time, but I will have an open circle at negative 6 and an open circle at negative 3. What is the derivative of the next part? What's the derivative of this function? What's 0? So I give the derivative a height of 0 all the way across, and again, open circles where I have discontinuities. What's the slope? 0. So that's where I put the height. Can everybody look at these two and convince themselves that that's the derivative of that part? Okay, now we're going to try something more difficult. Look at this graph right here. If I were to draw a tangent line on this graph, would the slope be positive or negative? Negative the whole time, right? The slope would be negative the entire time. However, what is the slope? If you were to estimate the slope way up here, what would you say it? It's super negative, right? Like negative infinity. Slope here, closer to 0, right? So the derivative that I graph, I will start at a value of like negative infinity, and I will move towards a value of 0. But the whole time, I will stay negative. I will stay below the x-axis. So this derivative, the graph of this derivative would look something like that. I have a very negative slope here, stays negative the whole time, but slowly gets towards 0. In fact, we could even put a vertical asymptote in there if you would like. How's that? A for the day. Who can guess what the derivative or where it's not differentiable on the next spot? It's not differentiable at 2. 27 is the time. It's 25 right now. Why is it not differentiable at 2? It has a vertical tangent. And if you have a vertical tangent, meaning if you drew the line that was tangent at that spot, it would be a vertical line. It is not differentiable at that spot. Now, if I sketch a tangent line anywhere on here except for that spot, will the slope be positive or negative? Positive. Everywhere you draw a tangent line on here, it will be positive. It's only at this one spot that it's not differentiable. Looks like we're calling lunch right now. All right, no bell today. Why don't you guys go? We'll be back. We just have to finish off this one, then you'll get your worksheet. Please hustle back so we can get to your work. It's your work time. The reason why this is not differentiable at 2 is because it's a vertical tangent. Now, Hannah said before we left that the slope of this is always positive except at that vertical tangent spot, correct? But as you go further to the right or further to the left, the slope becomes closer to 0, right? So as I draw the graph of this derivative, I will be close to 0, but I will be on the positive side. When I actually get close to 2, what is the slope approaching? Yeah, positive infinity, right? So this slope is going to explode vertical. Right after 2, if we go just to the other side of 2, what would you estimate the slope to be? Again, positive infinity. And it would slowly then move out towards 0. Andreas doesn't like it. Part of the reason Andreas might not like it right now is because the slope of this one is negative, isn't it? But we're not worried about the slope of this one. We're worried about its location. Is this graph on the right side here, is it above or below the x-axis? That means it's always positive, correct? And the slope of this blue function here is always positive. So it has to do with the location, not its slope. If you start looking at the slope of the green, you're finding the second derivative, which we do not want to do. And that's a, yes, I mean, I could graph the second derivative and it would look different than the first derivative, but we're not doing that yet. We'll look at second, third, fourth, fifth derivatives, but right now we're just looking at first derivatives. Question. There are, and we will look to find those and we will expose them quickly so we can find quick ways to go through. We will be showing you guys a lot of shortcuts when we get back from break, without a doubt. But the algebra does increase in difficulty. Can I just make one more point before I show you your worksheet? At all of these spots where it's not differentiable, look at the green graph. Is this continuous or discontinuous at -2? So if the graph is not differentiable, then the derivative will be discontinuous at that spot. Not differentiable here, discontinuous. Not differentiable here, discontinuous. Not differentiable at 2, discontinuous. Does that make sense? Have you owned that in your brain? Okay, we stop. We turn